Good afternoon, this is Ms. Parks, and we are about to finish chapter 4. So for section 4.6, this is inverse of a function. So you're going to learn what an inverse is. It's basically when the x's and the y's are switched. So all the x, y points become y, x points, and then that would be an inverse function. So here we go. So for the first part, they're not actually asking us to write an inverse, but it's very closely related. So the first thing they want us to do is solve they're going to make y is equal to the f of x function, and then we're going to solve for x. So for part A, we're going to take the equation y is equal to 2x plus 3, and we're going to solve for x. So that's what an inverse function does. It kind of undoes this. So like if you notice x, it's multiplied by 2, and then we add 3 to it. So we're going to undo that. So the first thing we're going to do is we're going to subtract 3. So then we're going to get y minus 3 is equal to 2x. You have to subtract 3 from both sides. And then you're going to divide both sides by 2. So x is equal to y minus 3, the whole thing over 2. Now it's just easier to go ahead and leave it like that, and we solve for x. Now you could have divided this by 2, and that by 2, and got y over 2 minus 3 over 2 is equal to x. I'm going to go ahead and leave it like this. The second part is asking us for part B. They're asking us to find the input. Input is always the x value, okay? When the output is -7. So I'm trying to find x when y is -7. Now I could use this equation, but we're going to use the equation that we just found in the last step in order to do part B, okay? So -7 minus 3 over 2, which is -10 over 2. So x is equal to -5. And that's pretty much it. Okay, so what that means, this is that when x is -5, y is -7. And that would work here as well as here. If it doesn't, then something's wrong. You should be getting exactly the same answer if you plugged in -7 here. If you plug in -5 here, you should get -7, so on and so forth. Go ahead and do the next example. And then when you're finished, come check your work. All right, so y is equal to 3x minus 5. So we have to undo the subtracting 5. So we're going to add 5. And then we're going to divide both sides by 3. You divide both sides by 3, you get y plus 5 over 3. Please don't write it like this, because then the 3 looks like it only goes to the 5. And make sure that your fraction bar is long enough to go underneath the y and the 5, please. Next, for part B, they want us to find the input. So we're going to find x when y is -11. So we're going to put a -11 into there. So that's going to give us -6 over 3. And x is -2. So that's the answer to that. All right. Go ahead and try the next 3 problems. Same thing as we just finished doing. All right. So the first part, y is equal to, you should finish all these before you play this part, okay? So if you haven't already finished them, pause the video, finish all 3 of them, and then come play this part to make sure you understand. So we're going to solve this for x. Y plus 2 is equal to x. And you can just leave it like that. You don't have to rearrange it. I know a lot of people want to write the x first. Second portion, find the input when the output is 2. So when y is 2, find x. All right, so we have x is equal to 4. Second problem, y is equal to 2x squared. So we have to divide by 2. So y over 2 is, so by the way, when you're solving, you're doing the order of operations backwards, okay? Order of operations backward. So when you have, please excuse my dear Aunt Sally, then you're solving an equation for a different variable. You can do the adding and subtracting first, multiplication and division second, the exponents third, and then the parentheses, okay? So And again, that's for solving. PEMDAS backwards. All right. All right, so there's no adding and subtracting here, so we have to do the division next. So we'll divide both sides by 2. And then we have to undo the exponent by taking the square root of both sides. Now, here's the deal on this. We have the square root of y over 2. You're not really supposed to leave a radical in the denominator. So we need to fix this. So in order to fix this, we need to make the bottom a perfect square. So we're going to multiply top and bottom by 2 so we can get this out of here. All right, and so then that will give me, I'm going to go up this way. At the top, I'm going to have the square root of 2y. At the bottom, I'm going to have a 2, and it's outside because that's the square root of 4, which is 2. So that's x. So that's my first one simplified. Now, when we want to do the second part, we're going to plug in a 2 for the output. So that's for the y. Okay, so we're going to plug in a 2 in for y. So then what we're going to get is the square root of 2 times 2. So that's 2 over 2. So that's 1. Now, one thing that was forgotten, and I wonder if any of you noticed this, is that as soon as you take a square root of both sides, you have to put a plus or minus on this side. So this is going to be plus or minus the square root of y over 2. So this is plus or minus, and this is plus or minus, and this is plus or minus. So anytime you take a square root or an even numbered root of both sides of an equation, you must follow that with the plus minus. Okay, so those are only for even roots. So if you take even of both sides of an equal sign, then you need to include a plus minus in the answer. All right. For the next part, y is equal to negative x to the third plus 3. So order of operations backwards. So we're going to do subtraction first. Y minus 3. We're subtracting 3 from both sides. Then division next. So we're going to divide both sides by negative 1. So here's what happens. When you divide both sides by negative 1, then this becomes negative y plus 3 is equal to x to the third. Then, to undo this, you're going to take the cube root of both sides. You don't need a plus or minus here because it's not a square root. So that's the formula. And then they want us to plug in the number 2 for the y. Okay, so for part B, we're going to take this equation and we're going to plug in a 2 for the y. So it's going to be the cube root of negative 2 plus 3 equals x. Cube root of 1 is equal to x, and the cube root of 1 is 1. All right, so now we have inverse functions. And inverse functions, we're actually going to get to them finally, are functions that undo each other. Okay, so in the very first example, you can use the equation that we solved for x to write the inverse. So for example, let's go back to the very first one that we did here in example 1. So if the f of x function is equal to 2x plus 3, then the inverse function of x, okay, so this is inverse, is this equation, except for the x's and the y's are flipped. Okay, so this is the function, and this is the inverse function. So if we use the functions like we did in the composite functions, and we plug this into this, you would get x. They would undo each other. So if I plug this one in here, you would get x. If I plug that one in there, you would get x. Okay? So let me write the steps down on finding inverse functions. There are 3, okay? So I'm just going to put it to the side here. Number 1, to find inverse functions, you're going to change the f of x to y. You may not have to do that part. It depends if they give you an f of x function. Number 2, you're going to switch x and y. And number 3, you're going to solve for y. And that's it. Okay? So, let me make this a little bit smaller. So here we go. So, first question, I'm going to go ahead and follow those 3 steps. I'll leave them so you can see them there. So, step 1, y equals 3x minus 1. Change the f of x to y. Step 2, we're going to switch the x and y. So you physically actually rewrite the letter y as an x and take the letter x and change it to a y. And then step 3, we're going to solve for y. So in order to solve for y, we do the order of operations backwards. So we're going to do the addition subtraction first. So we're going to add 1 over to this side. Now, if it helps you to do like this, plus 1, you can go ahead and do that, okay? But if you move an addition from one side to the other, it just changes the sign. So that's 3y. And then after, we're doing the order of operations backwards. Okay, so we do this first, this second. So 1, 2, 3, 4 when you solve. Okay, and then we're going to divide both sides by 3. So you're going to get x plus 1 over 3 is equal to y. And that is, these two are inverse functions. Okay, they're inverse functions of each other. You will see the inverse f of x notation. So you don't have to do that for my class. You could just write it y is equal to x plus 1 over 3. But you could also write it the inverse function of x is equal to x plus 1 over 3. Go ahead and try number 2, please. All right, first step. Hopefully you finished it already. You paused the video, so I'm not going to sit here and wait for your time. Go ahead and pause it, finish it, and then come try it. Actually, go ahead and do all 4 of these. Okay. All right, plus 8. Change the x and the y. Now we're going to solve for y. So I'm going to add 8. And then I'm going to divide both sides by 2. Now, you cannot divide 2 and 8. You can only reduce this fraction if all 3 terms have coefficients that can be divided by the same number. Okay, so like if you add 2x plus 8 over 6, then all of these are divisible by 2, and you could write it x plus 4 over 3. That would be okay. But you can only do that if they're all divisible by the same number. All right, so for number 4, change the f of x to a y, and then switch the x and the y, and then solve for y. Pretty simple. Next one, change the f of x to a y, switch the x and the y, and solve for y. So I'm going to solve for y. If you wanted to add y to this side and subtract x, you could. I'm going to go ahead and subtract 1. X minus 1 equals negative y. And then I'm going to divide everything by negative 1, which changes the sign of everything. Okay, it changes the sign of everything when you divide everything by negative 1. Last one, y is equal to 1/3 x minus 2. Switch the x and the y. Now we undo this, so we do addition subtraction first. I'm going to add the 2 over. And then remember, we never divide by fractions. So we always multiply by reciprocals. So because this is 1/3 times y, we're going to multiply both sides by 3 in order to undo that. So we're going to multiply this side by 3 and this side by 3. What happens is we distribute here. We get 3x plus 6. And then here, 1/3 times 3 is just 1. Okay, that's really 3 over 1 that you're multiplying both sides by. Okay, and that's it on that one. Let's see what we got next. We're not going to do a lot of these graphing ones right here. Let's go ahead and scroll past that. I just want you to know that, like, if you're doing an inverse function in a graph form, let me actually highlight this a little bit bigger. If you were to draw a line, let me see. All right, let me change this color up. Maybe not make it so thick. Extend that out a little bit. All right, so this is the line that goes right at the 45-degree angle, like cuts all these in half. So if I could take this and fold it along this line, okay, or you can even take specific points. Like this point is 0, 1. This point right here is 1, 3. And this point right here is -1, -1. And let's pick, well, actually, let's just pick those 3 points. Now let's flip. These are my xy points. And then for my inverse function, we're going to flip them. And my xy are going to flip. So we're going to have 1, 0, 3, 1, and -1, -1. So let me plot those points. 1, 0. So this point went boom, and it flipped over. This point is 1, 3. It becomes 3, 1. So this point went from here to here. And then -1, -1 is the same exact point. So if you can kind of see, this goes like this. This one's going to go like that. And then it's going to go here because that's where it turns. And so if you can try to picture it folding along this line right here, that's what an inverse function does. You could literally take the x's and the y's and flip them over. Like if you wanted to do more than that, you could take this point right here, and that one would go there. So like -0.8, 0, and then 0, -0.8. If I wanted to take this point right here, it'd be like 0.8, 0.6. So I can go 0.6, wait, 1 point, sorry. So this would be like 0.8, 1.6. So I go like 1.6, 0.8. So it would be like that. So that's what an inverse function does. If you can fold it along the 45-degree axis, and then you can change all the x's and the y's, that would be an inverse function. All right, let's go ahead and actually do some of these. Okay, so let's go ahead and do this example. All right, so we're going to work this out and find the inverse function of this. So y is equal to 3x to the third minus 2. Then we're going to switch the x and the y. So x is equal to 3y to the third minus 2. And then we're going to solve for y. So we're going to do the adding and subtracting first. So that's going to become x plus 2 is equal to 3y to the third. Then we're going to undo the multiplication and division next. So we're going to divide both sides by 3. So if I divide both sides by 3, I'm going to move this way, then that's going to give me x plus 2 over 3 equals y to the third. And then the last thing I have to do is get rid of this exponent. So I'm going to take the cube root of both sides. These will cancel, And then on this side, and we don't have to do a plus minus because that's not an even number. Some people will leave the answer like this. Let me just be honest. Some people are going to leave the answers like this. Some books will leave the answers like this. I don't want you to do that. So we want the perfect cube root at the bottom. And so in order to make a perfect cube root at the bottom, that the first perfect cube root that 3 goes into would be 3 times 3 times 3. So this needs to be 27 at the bottom. So I need to multiply top and bottom by 9. So that's a perfect cube root. Okay, so at the top, I have 9x plus 18. And at the bottom, and that's in the cube root. And at the bottom, I have the cube root of 27, which is 3, and then I have y. So you can leave your answer like this, or if you wanted to write it, the cube root of 9 times x plus 2 over 3, that would be okay also. All right. It's going to take some practice, and so you can kind of see at which point you guys have to simplify things and which points you do not, which usually you have to simplify everything. All right, so we're not going to, and I know it says to determine whether the inverse of s is the function. We're not going to answer that part yet. I just want you to find the inverse functions for right now. Please go ahead and try both of these, and then I will go through them with you. So we're going to actually do these 2 and these 3. So if you wanted to do all 5 of those, at least to the best of your ability, go ahead and do that. And then check your answers afterwards. Okay, so if you get stuck on one, this just means that x can't be negative, so you don't have to worry about that part. Okay, that's all the reason they're giving you this, is to let you know that x is not a negative number. Okay, all right, so let me go ahead and do this one. Y is equal to, this is me doing them after you've already tried them all. Okay, switch the x and the y. Now, we cannot add 3 over, because even though I know the order of operations, we can't add 3 because it's in this radical, so we actually have to divide both sides by 2 first. And then the opposite of square rooting something is squaring, so we're going to square both sides. So this is going to become x squared over 4. And then we'll add the 3 over. So the last thing we're actually doing here is adding this 3. So we're going to get x squared over 4 plus 3 is equal to y. For this one, we're going to have y equals 3 times the square root of x plus 4. Then we'll switch the x and the y. Then we have to divide by 3 because that 4 is in the radical. We can't move it. So we're going to divide both sides by 3. Then we will square both sides. When you square a fraction, you square the top and bottom separately. And then a square and a square root cancel each other out. And then we're going to subtract 4 from both sides. All right, so that's it for that one. Actually, we might do other ones. Let's go ahead and do these. So y is equal to negative x squared. X is equal to negative y squared. We have to divide both sides by negative 1. And then after we divide both sides, actually it does say that x is negative here. I said that it wasn't, but it does say x is negative. And the reason they're saying that x is negative is because if you have a negative negative, that becomes a positive. So that means that we can take a square root of both sides. So y is equal to plus or minus the square root of negative x. Okay. And x will be a negative number. And because x is a negative number, when you plug a negative number into this equation, it makes it positive. Okay. So it's telling us that x is a negative number. So a negative negative will become a positive, and that means that we're allowed to take the square root of that. The next one, y is equal to negative x to the third plus 4. So we switch the x and y. We have to do addition subtraction first, so subtract the 4. Then we have to do multiplication and division, so we're going to divide everything by negative 1, which basically changes the sign of everything. And then we're going to take the cube root of both sides to undo that exponent. So we're going to get the cube root of negative x plus 4 is equal to y. We don't have to worry about a plus minus because that's not an even root. And then this one, y is equal to the square root of x plus 2. So x is equal to the square root of y plus 2. We have to get rid of that radical. That's the first thing, because we cannot subtract 2 when it's underneath the radical. The radical acts like a parenthesis, basically. So we're going to square both sides. These will cancel. And then now we could subtract 2. So you're basically saying, what's happening to x here? We're adding 2 and taking a square root. Okay, adding 2 and taking a square root. So what are we doing to x here? We're squaring it, and then we're subtracting 2. So we're undoing these. So we're undoing a square root by squaring, and then we're undoing a plus 2 by subtracting 2. Okay, so that's what an inverse function does. All right. Next, we're not going to graph those. The functions are already there. Those are the ones that we just finished doing. And they just want to verify that these two are inverse functions. So there's more than one way of doing it. You can plug one into the other and see if you get x, or you can just find the inverse function of one and see if it equals the other. So that's what I'm going to do. I'm going to find the inverse function of f of x. So y is equal to 3x minus 1. Switch the x and the y. Add 1. And then divide by 3. Since that is that, then the answer is yes. So last problem, go ahead and try this one. Answer whether or not they're inverse functions. And then that's it for chapter 4 and section 4.6. All right, so I'm going to write the inverse function of this. Hopefully you guys already did this. So switch x and y. Subtract 4. Divide by 2. That is that. So yes, they are inverse functions. Now I'm just going to show you really quick that if you plug one into the other, you should get an x value. So if I take this and plug it into that x, this is what's going to happen. I'm going to get f of x is equal to 2 times x minus 4 over 2 plus 4. And then these will cancel, so you're going to get x minus 4 plus 4, which is x. So if you plug 1, so it's basically if I did f of g of x, the answer would be x. And if that's the case, then that means that they are inverse functions. All right? So that's it. We're not going to do the rest of the section on here or the rest of the problems on here. I will provide some homework for you to practice this stuff, and then we'll talk about it in class.